Okay, so in this question 8 of paper 2, we've got a vehicle travelling along a straight stretch of highway. The driver notices a car stalled on the highway k meters ahead and applies the brake of the vehicle. The acceleration of the vehicle t seconds after the brakes are applied is given by this formula: acceleration equals negative 10e to the negative 0.1 t. It's worth noticing that we're talking about seconds and meters in this question, so that we get our units right later on. Okay, so part A just says determine the initial acceleration. So remembering that acceleration is negative 10e to the negative 0.1 times t. Now initially, that's when time is equal to 0. So we're going to sub in a 0 there, giving us negative 10e. And when we multiply out this power, times it by 0, the whole thing is going to equal 0. And remembering e to the power of 0, or anything to the power of 0, is 1, so we get negative 10. We've already said that our units are in meters per second, so acceleration is going to be in meters per second, like that. Part B of the question says, well, determine when the acceleration is negative 8. So we're going to use the same formula, but set it equal to negative 8, like so, remembering to sub in a t then. And we can literally put that into our calculator in Solver, and it will spit out that t is equal to 2.23 seconds. Okay, so far we've got 3 marks complete of this question. Part C says determine an expression for the velocity of the vehicle t seconds after the brakes have been applied. Well, velocity, we've got acceleration. To get velocity, what we need to do is do the integral of the acceleration, which is negative 10e to the negative 0.1 t. We're going to integrate that with respect to t, so we're going to put a dt on the end. So when we integrate this, we're going to have our e to the negative 0.1 t. That's not going to change when we do our integration, but we do need to divide by the derivative of the inside, the derivative of this bit here that I've just turned orange. So we're going to divide by negative 0.1. So it's going to be negative 10, if you like, negative 10 divided by negative 0.1. Well, that looks a little bit messy. Okay, it's the negatives will cancel, and it's 10 divided by 0.1. Remember, 0.1 is 1/10, so it's 10 divided by 1/10, or 10 times by 10 there. So it's actually going to become 100. But remembering, of course, that you've got your calculator in this section, so there is no need to make a mistake with manipulating these fractions. We could have just popped it in. When we've integrated, we should have had a plus c on the end there. So that is an expression for velocity, and that's all we can do. We've got no other information to work out this constant of integration at this stage, so we just leave it like that, and we'll move on to part D. Part D of this question, determine an expression for the displacement. So I'm going to use S for displacement, and we need to integrate the velocity. So we're going to integrate 100e to the negative 0.1 t plus c, and we're going to put our dt on the end. Don't just think we don't know what c is, so let's leave it off. We need to put the plus c there when we're integrating. So off we go. We're going to have 100, and again we're going to divide it by that negative 0.1, so it's going to become negative. Remember, when we're dividing by 0.1, it's the same as timesing by 10, so that's going to become 1000 e to the negative 0.1 t, plus, when we integrate a constant, it would become ct, and then we would get a new constant, which I'm going to do as plus d on the end there. We don't want to do plus c again because it's a different constant of integration that we get. So we get that. Now what we're told in this question in part D is that the initial displacement is 0 meters. So that is S of 0 is 0. Okay, so that is The displacement is 0 when time is equal to 0. So when we do 1000 e, that would be to the power of 0 when we sub in t is 0, plus c times 0 plus d. Okay, so all of this, that's going to equal 0, and that's going to equal 1, remember? So it's just going to be negative 1000. So hopefully you can see from that that d is going to equal 1000. Okay, so we get our expression for displacement. S equals negative 1000 e to the negative 0.1 t plus ct plus 1000. We still don't know what c is. That is okay at this stage. Okay, moving on to part E of the question. Let's have a read of what that says. The vehicle comes to a complete stop after 3 seconds. Okay, so that means that the velocity at 3 seconds is equal to 0. If it comes to a stop, it's not moving, its velocity is 0. That's what that bit means. Determine the initial speed of the vehicle. So we can use our velocity formula, which we know up here. And we can say 100 e to the negative 0.1 t plus c. And if we use that after 3 seconds, the velocity is 0, we get 100 e to the negative, when we sub in 3, we get 0.3 plus c. Okay, so therefore we can solve for c just by moving that 100 e to the negative 0.3 over to the other side. So c would be negative 100. Or we could put it in our calculator, which we'd probably do because this is a paper 2, and get that c is negative 74.08. So now we know that the formula for velocity is what it was before, but we now know that this is not positive, it's negative. Let's get that right. Negative 74.08 on the end. So now we know that. Okay. What did the question say again? Find the initial speed. Well, speed is velocity. Okay, so we go velocity is 100 e. Initial means time is 0, so it's going to be negative 0.1 times 0, so I'm just going to put 0 there, minus 74.08. So remember, 100 times e to the 0, that's just going to be 100 minus 74.08, and that's going to give me an initial speed then, when I do that subtraction, of 75.92 meters per second. Now, I said a moment ago that velocity was speed, and it is, but remember, velocity has a direction, so this could have given me a negative answer for velocity, but I wouldn't have given a negative answer for speed, so I would have just ignored that negative, but in this case we didn't need to worry. Okay, that's our answer for part E, and we've just got part F to go. We're doing pretty well so far. Find the value of K. Well, what we know is that they stop directly behind the vehicle. That's the key. We have to assume that they're pretty much touching it. So the distance they've travelled after 3 seconds is how far away the car was, and K is how far away the car was. So K is S of 3 seconds, the distance after 3 seconds, which is going to be our displacement formula, which is just above where I'm writing now in red, negative 1000 E, and I'm subbing in that T is 3, so that's going to become negative 0.3 minus, now I know that C is 74.08 times 3, and I also know that D is 1000. Let's see if I can squeeze that in. Okay, and we just tap that into the calculator, and we get that the value of K then equals 36.94 meters for our final 3 marks there for the end. So that's the end of that question. It was pretty tricky, but you needed to remember to get from acceleration to velocity, you needed to integrate and you needed to divide by that 0.1. That's where a lot of you got caught up. And then to change velocity into displacement, you needed to integrate again. And remembering to have that plus c, your constant of integration, and then introduce a second constant of integration when you integrate a second time. So I used d.